Today we do a MDTools demonstration, and since during last HydroCAD webinar I've been drawing this power unit, small simplified power unit diagram, and there was a manifold, and in this manifold we have some sleeping valves, and I never used any sleeping cartridge valve in my previous webinar. So today I decided to make this manifold. It's not complicated. We have a filter, we have a couple of sleeping valves. Maybe we had a relief valve, we had some test point. But so today's exercise is making this manifold in MDTools, using MDTools. I'm not using today the Hydro to MDTools interface, but I'll use the HydroCAD diagram to explain a bit of items for MDTools. So people using HydroCAD to MDTools know that we have a command called net, and a net command is able to find the connectivity in the block, which we can use to verify if we made all the connections. And now I just highlight the connections that I'm going to consider. So there is this connection, I will call it P. Then there is another connection that I will call line. Let's say line. Then after this item, there will be another net called P1 that is collecting all the ports for the sleeping valves. We have a drain line, we have a tank line. So it's not very complicated, but it's a good exercise. So my task today is design this manifold, make the assembly, and make the machining drawing. And if you have any questions, just feel free to ask, to put in the chat. If we look at the components, well, we have some flanges. The tank is 1.5 inches, code 61. The pressure is 1, code 62. We have a BSPG 1x2 for the drain, and we have NG25 for the sleeping valves. And we have a filter that is, in this case, EPF4 Parker filter. So although it is written here Bosch Rexroth, I just EPF4 because I know I have a 3D model and I have also the cavity in my library. So let's consider it a Parker EPF4 filter. Let's jump to MDTools. I will start a new part. And we know that MDTools is a plugin for either Inventor or SolidWorks, and you will find under the add-ins, and you can load the version that you have for MDTools. So now I'm loading MDTools 780 in Inventor. As a first setting, I will just go into my configuration for MDTools, and except for the library, which is normally something that you never change, I'm going to verify that I'm using the BSP plugs. So my design will use BSP plugs. If you don't want in a design a certain set of plugs, you can just remove and add different plugs. I get back again to my BSP plugs, but here you could use MPTF, short ports, expander, or whatever you need. So I just added my BSP plugs and click apply. This will make the changes to my setting, and now I can start my design. Of course, we always start with a block, and we have the possibility to select a material. And if you need to define materials and cross sections, you can go directly to the library manager, MDTools library manager, and there you find all the possibility to define plates or bar, and you can put the rough dimensions, raw dimensions. In this case, really, I don't need, let's say that I want a 250 by 180 by 180, and then we'll see if this is fitting or if it is too large. Now I go a bit with memory. We had a filter, and the filter was an EPF4. So you can search the cavity. If you know the cavity name, you can just search. And we remember that it was entering with a net called P, and it was ending with a net called line. You can specify any net name you want. The advantage of defining net names also in Hydro, it is possible, is that then it is easy to recognize. And when you type a net name that is matching a net name in the cavity color, in MDTools settings cavity color, then for sure that net will have exactly the color that you expect. So in my case, I have no net called line in my settings, so it will take the first color that is in this table. But of course, it is possible to change color. So let me define the component ID. Let's say this is the filter. And usually component ID is the ID in the diagram, so it should be item 101, but really you can put the name that you want in order to recognize that. So I can insert, and let's say that I want to put the filter on the back face, and let's say that I want to be somewhere here. There was an inlet, it was a flange, so let me search for a 1-inch code 62 flange. The net name is my pressure, P, and that's my component ID is the pressure, and I put it here, maybe on the left face. So ideally, when you design a block, you of course you envision where you need to place the component. So in my vision, I want to have the P coming from the left. I will have the P2, P1 exit on the opposite face. I want a tank line down on the bottom face. There is a large slip-in valve which we will put on top. There is another slip-in valve, but only with a cover, so this will be okay in any position. And that's it. And then we see how things are going. And there is another tank flange, which maybe we can put here or on the front face. This is our strategy for today's design. So I put the P port, and now I can connect directly with this line. In the center, we can rotate, and we can move the flange where we want. As you can see here, we have the position, and now the position is from this vertex. So let's say that we want to make it 60 millimeters. Okay, and this is making the connection. There was an NG 25 slip-in valve, so we find it in the folder slip-in cartridge ISO 7368. We take the NG 25. So the NG25 was taken, it was in a functions of a check valve. So the inlet was the line, and sorry, the inlet was the P, and it was ending with the line. No, that's line, and then it was ending with the P1. Let's get back to the diagram. So it was taking the line and was ending to the P1. So it's always easier to import a diagram made with HydroCAD, but it's not mandatory. So in this case, I'm trying to design without the HydroCAD interface. X is taking the same P1 signal, and there are no drain Z1 and Z2. The component is NG25-1, and we can insert. Let's try to place on the top face, and then we see if this is good or not. So now I can see that the color is not good. Let me verify what is the name of the net. Maybe I put a wrong net name. NG25. Yes. As you see, I put P line. So in this case, I have a yellow color instead of the purple one. So let me change the net into line and save. So now the color will be the same. So I expect to connect these cavities here. Of course, the way it is positioned will force me to make the block much taller. So now my strategy is to change phase to this cavity on the front face and do the connection. In any case, during the design, you can verify if you are doing good. So if you do the connection check, of course, I am at early stage, so I don't need to always run connection check. But in this case, the connection check will warn me that I have wrong connections because, of course, my filter is touching the so the filter is this one and is touching the nose of the sleeping valve, and also the pressure is touching the same. And this is a wrong connection, of course. In addition, the connection check will warn me if I have a broken net, and in this case the pressure isn't open and also the line is open. Let me clean up and let me start doing some more items. In this case also I have grayed out port. This cavity does not need X, Y, Z1 and Z2, so I can just delete them. Delete. When you delete items in a footprint, just make sure that you don't select the delete complete footprint. So in this case, I'm just deleting 3 items for the same footprint. And now I want to change phase to my cavity and position it here. And maybe I just, if you want, you can just position with a reference let me take a reference, the opposite cavity, and exactly in the center 0 0. So in this case I'm making the cavity exactly on the opposite face in the same exact position of the filter drill. So I can click OK. Now this is much better. I just need to stretch my drill and make it longer. So stretch, take the drill and stretch it. When you have 2 coaxial drills, the connect cavity is not working, because connect cavity is only working with side drills. So in this case, the only way to make connection is use stretch drills. Now we had another NG25. It is already selected. This one was always taking the P1 on the side, but the nose was going to tank. And in this case, we have also a drain, which is Y. And that's the NG25-2 item, which we put somewhere here. So we decided that we want on the top face, and we put it here. Again, we don't need all the Z1 and Z2, so we can delete as we did earlier. We can rotate the cavity if we want, so we can say rotate and make it 90 degrees so that the orange connection is coming in this direction. This block had also a flange. So let's go to the flange, 1 inch. It was called P1, always for the same net P1, and we place it here and connect it to port number 2. We preview, we can rotate it, and we can move maybe slightly down and click OK. This one can be rotated so that we don't need to make an additional connection, so we can rotate this footprint by 180 degrees. Now we want to connect all the orange, so we make a construction plug on port number 2. It is taking a very large drill, G1 1 inch 1x4. We just need maybe a 1 inch. Continue, and we place it here, and we click OK. And so this is our connection. If you remember, I was willing to place a flange on the bottom face. So let's go into the SA3000 and take the flange 1.5 inch. The net is the tank, and the port is a T, and we place it here. and I want to position in the center 0, 0. We can rotate if we want and click OK. Again, to make this connection, we just use the stretch drill and make the connection. There was another flange called T1, which we put maybe on the front face and connect directly here in the center. And let's say that we want it at 120 millimeters. That is good. We need also the drain port. It was a BSP port G1/2. The net name is Y. It's a drain, and we call it drain, and we insert here. Let's put it somewhere here, maybe at 140, 70 millimeters. Now we can make a construction plug between these cavities. 1/8 is enough, and we can create the connection. Instead of a construction plug, we may decide to make an inclined drills. So let's remove this drill and say stretch. I want to stretch this drill with inclination, go to the drain line. We can see a preview, and we can change the drill inclination. Let's make it degrees, should be enough. And let's make it 75 millimeters deep. In this case, MDTools is warning me because when I incline the drill, of course, the profile, there will be as an ellipsis here on top that may exceed the maximum diameter. So MDTools will give me the maximum value I can make to match that the maximum 6 millimeter diameter for this drill. So 5.9 is not bad. So I could say yes, but if you want to be precise, you can change and select a different drill. If you click on the small diameter icon, then you have a list of diameters available and maximum length. So in this case, I will take the 5.5 with maximum length. So you have also information of which drills you have available, and also how deep you can go with that drill. So 5.5 is okay. So I take this one and click OK. And now MDTools is creating my inclined connection. Let's get back to the diagrams to see if we forgot anything. Let me put both in the same screen. So we have the pressure entering and going into the filter. Then we have the filter going into the logic element, the first one, and then we have yes, I can see there is a mistake here. So this connection is coming from the nose. So this net, we can do the edit, and this net is not P1. The X is going into the line. So we make it and select the connection that is called the line. So now I will need to fix it. The rest should be fine. The drain and the tank is okay. So let's try to find out a solution here. So in this case, I cannot make the drill this way. So I will need to rotate my cavity. Let's turn back to 0 degrees. Now I don't need anymore the inclined drill, but let's leave it. That's not a problem. Let's move this here. And let me stretch the drill here. And I need to connect. In this case, this missing connection is always highlighted by the connection check. So it is saying that line is broken, X is unconnected. And then there is also another issue here, which is an intersection between a bolt hole. This may not be that big issue because there is not really the bolt hole inside here, but we don't want this, so we will rotate later this flange. So as you can see, the connection check is not only verifying if you made the proper connections in the block, but is also verifying possible interference between items or cavities that you don't want in the block. So we make a construction plug here. 1x8 is enough. We put on this face, and we can use the reference to make it exactly in the same axis, 0, and click OK. And I can rotate this flange. Let's see if it is fitting. Yes, it's okay. We can also move a bit, move multiple. This drill, this one on the Z direction by 1, 2, 3, 4, 5 millimeters. And this is also okay. We can run a wall thickness on our manifold wall thickness check, and we can verify for 5 millimeters around all the cavities. And we have a list of issues. So we have an issue of less than 5 millimeters, always here between these two cavities. This is really not a threat in this case, so I will accept it. That's not a problem. Everything else is fine. In case of large cavities, sometimes I like to do a checking around a particular cavity, maybe for a larger diameter, let's say 8 millimeters around this, and do the checking. So in this case, I can have all the verification of potential wall thickness issues on larger drills. Of course, in this case, 8 millimeters is enough to make the same drills in the same footprint to be highlighted. But in this case, really this is the footprint, so we cannot change the position of the drills. Let us add some mounting holes. So we want mounting holes. M14 is enough, 4 pieces on the bottom face, and we click OK. We can also reduce a bit of material, so let's just stretch this face and make it 170. Maybe we can also remove material, create, and we can remove material also on the width here, and we can say remove 10 millimeters here also. And also in the length, we can say that on the length here, we can remove 10 millimeters. Let me save my block. Webinar MDTools 4. I want to add some engravings. So to manage engravings, okay, I see a question regarding the stretch drill. So let me answer since we are in the design mode. So to stretch drill, we use this command, stretch drill. Let me highlight stretch. Stretch, we touch the cavity, and we can just take the tip and put it, drag it up and down, or we can use the stretch up to and select the cavity as a destination, so it will end center to center with that cavity. At the same time, when you use the stretch, you can also make an inclined drills, and looking at the preview. Beta and alpha. Alpha can be 45, 90. You can lock alpha and lock beta, so then you can stretch the drill just on a fixed direction. Or if you unlock beta, then the drill is free to also change inclination on that locked alpha. So this is the stretch drill command. Let me add some engravings. So we can use the manage engravings and attach to maybe here. That's my drain, engrave. And then here I put my engraving here, P1, engrave, and so on. Engrave. Engrave. Let me save my block and let's go to assembly, and maybe we get back to do some modification if needed. So we make a new assembly and we start. I have not loaded the diagram, so it is not possible to make an automatic assembly. So I will make a standard plug. So I will put all the plugs in block, and the block is webinar MDTools 4. So there are not many plugs in this case, so just one here and one here. Later maybe we add more. And now let us add some components. So when we load components, we have a picture of all the items in our block. So I select my tank lines, I go to select cut files, and I go to my flanges, and I take my socket welded flange, and then I go to my pressure and I select my flanges 1 inch. Then the first slip-in valve had I have some logic element for Rexo, so LC search LC25, and then I have LFA 25D, just the cover. Okay, and for the other one we have always the insert LC25, and then we have an LFA. I don't remember the model code. It should be this one, DBW. Yes, that's with the relief valve. And the valve on top, since there is an NG6, I will put manually with the inventor or SolidWorks command. And the filter, I will go and search for a EPF4 filter. And that's it. We can put a nip fitting also on that one, G1/2. And we can update. So now our assembly is okay. On top here, we need to have the directional control valve. We can put with the standard commands. So the valve is 4W6D. We open and put it here. And then you can constrain with the standard commands for the CAD application. So we do this. This one is going to be here. And this one is going to be here. That's our assembly. Let's go back to, let's save it. Assembly webinar 4. Okay, let's go back to our block, because I want also to put a test point for the pressure and line. So let's go to BSP port G1/4. I need MP insert, and I want to place it on top and connect with the pressure line with a 6 millimeter diameter, and we put it somewhere here. I also want another one that's called MP1, which is here, and is connecting to port number 2, always with a 6 millimeter diameter. Again, we put engravings attached to this cavity, engrave, and here as well. We go back to our assembly and put also some test point. So we load components, take the MP1, and select files and go to our accessories test point, Minimes, and update. So now we have also the test point. If we need to share our 3D manifold with our customer, we don't want to give all the details, internal details. We can use the shrink wrap command that will save into we can make an assembly in the CAD application, or we can directly save a step file. So in this case, we can save a step file simplified that we can really give to the customer. He can put in his machine or power unit, and it will be okay. Later, I will look at the step file. In the meantime, I want to show you the machining drawing. So before doing the machining drawing, I go to the part environment and just run one command. Since I want to make the drill chart, I will run the machining ID command here. So machining ID is giving to each cavity in the block a unique ID that will then be related to the information in the drill chart. So my structure is using a number for the face, a number for the cavity, and a letter for identical cavities in the same face. So basically, like in this case, we have 1, 2, 3, and 4 identical bolt holes. They will have the same number for the face, same number for the index, and the different letters. So by using this structure, it is also possible to group identical items in the part list. So for industrial block, this is very convenient because frequently you have very standardized or identical operation when you have footprints with identical bolt holes. For mobile manifolds, this is sometimes it's difficult to have identical cavities in the same block. And by identical, I mean not only the cavity but also the drill depth, which is not normally changing in a block. But maybe next webinar, I will design a mobile manifold. So this one is a very simple industrial one. Let's go to the machining drawing. So I create a new and take my DWG standard drawing. The block, although it's not complicated, is a bit large. So I will just change the size and make an A0. It should fit in an A0. And I will first run the create views command. I can take my block and I can define the projection type, how I want to, where I want to put the sixth view. Now I want on the right, and I can click OK. So this is creating all the views for my manifold. Normally, I like to show the footprint information. So in this case, MDTools is adding also a letter for the port and the outline profile, so X, Y, and the cartridge. There is an inclined drill, so there is an arrow showing where the inclined drill direction is going. We can also show the machining ID, which is that number that I described earlier. So in this phase, that's phase 5, 500 A, B, C, and D, 503 and 502, and so on. I use different layers with colors to highlight and define different entities. It is possible to highlight plugs by using the construction port command. It will put a cross on each construction plug. If some texts are overlapping, you just double click and change the text position and close the sketch. And also here, maybe we just double click and put the filter in and out. We can put the dimensions automatically. So all the dimensions are there, and we can create a machining chart. My standard machining chart is made in a way that I want to group by quantity, and I indicate also alpha and beta, the depth, diameter, operational remarks for all the entities. But you can create several more machining formats. I want to use the cavity ID, machining ID, and I can insert in my drawing. So now my part list is going maybe from here down here. And that's my drill chart. And if we look at the drill chart, in this case, for the sleeping valves, that's item 107. I always put a remark describing which type of feature. May not be needed always, but that's my standard way of making the machining chart. The type of drill and also the bottom drill, how many pieces. And as you see here, we have the M12. There is the bottom drill and also the thread depth. 8 pieces because in that phase we have 8 M12. If we want to add an additional relief valve, we can go back to the block. Let's say that we need a Rexroth DBDS, DBD, maybe 10 size, a relief valve, and we put it somewhere here. And I want to create a construction plug. 3 by 8 is enough, and we put it down here. And then maybe we have a tank line. Let's see if we can put it this way on port number 2 on this face and tangent, and we can go slightly down. Okay. And of course, this was a tank line. And also this one is a tank line. So if we do a change in our block and now we want to update the machining drawing, this cavity had no machining ID. So in this case, I need to specify the machining ID, and we can say machining ID. If we have already delivered the drawing, we can keep the existing machining ID. So this option will make sure that all the other drills that were in the block keep the old machining ID, and only the new ones will get a new machining ID. This is okay for me now, so I click OK. And now I will go back to the machining drawing. And now MDTools will give me a warning that I need to update the drawing. So I click yes, and now MDTools will create the additional information. So we'll add the dimensions, we'll update the part list, and do whatever is needed. And here it is, and as you see, it took 207. So now if we go back to the drill chart, there will be item 207, Rexroth DBD 10K, and so on. I recently developed a small tool to put also the cavity symbols. This is working this way. So automatically I have all the cavity symbols for the cavities that I have in my block. So I have SA flanges 3000, 6000. I have the DBD 10K. I have the NG25, and I have all the BSP port in my block. If you need to display hidden views of the block, you can just run the show internal details command, and this command will create an additional file in the drawing with all the internal details of the block. We let it go, and we see the result. Feel free to post any question if you have. We still have 5 minutes, so we look at the step file. So as you can see, MDTools is creating the internal views. I don't use very frequently this command because it is always creating an additional part file that has to be managed. But it is nice because really it gives to the manufacturer the idea of how the intersections are made in a 2D drawing. Of course, manufacturer that has a CAM software really does not need this kind of view. So it's interesting because in this case, it's clear that this drill is before the sleeping valve that is behind. And so it gives you a bit of depth, idea of depth in the block. But as said, I don't use it that frequently. Okay, there is a question about the weight. So being able to display some attributes in the title block. And so it has nothing to do with MDTools. It has to do just with Inventor or SolidWorks. So it is possible to apply materials. And since the user asking is using SolidWorks, if I'm not wrong, I may explain how to do that in SolidWorks maybe separately. But really, the possibility to display attributes in the title block is only a characteristic of the CAD application. So I should have an example in SolidWorks. So I open SolidWorks and then I open also the shrink wrapped model in SolidWorks. So we see that it is creating. Okay, this is the shrink wrapped model. Okay, here we have SolidWorks. If I create a new machine drawing, this is a customer drawing, but these fields, weight, kilograms, are reading attributes of the part. So this is really, this is just the pure SolidWorks. And if you put a view of a block, let's see, this is something I made for a customer several months ago, so hopefully it is working. But otherwise, I may be able to explain separately. Let's take this one, 1/2. Okay, as you see here, the weight 5.6 kilos is updating after I put the so this is, and the material in this case is not specified because I had not specified in the block. So it is possible, and it is just a characteristic of CAD application. So it is doable in Inventor and in SolidWorks as well. If you need more information, I will be able to help. Let's try to open the step file in SolidWorks. So we see how the step file is looking. Of course, I had created before the relief valve, so this file has not the relief valve. Okay, this is the step file. And if we look at the internal, not really this. Let me view some transparency. Okay, this one, let me put some transparency here. As you can see here, there are no drills inside. Only, well, I had the sleeping valves, so you can see the cartridge, you can see the bolts, you can see the ports, but you don't see any internal connections in the block. So the shrink wrap is a simplified model, solid body that you can use to share the geometry with your customer.